Visual-Semantic Graph Attention Network for Human-Object Interaction Detection. Over the past few years, visual recognition of individual instances, such as object detection, human pose estimation, has witnessed significant improvements. However, to further understand the visual world, a machine requires not only detecting individual object instances, but also recognizing the interaction relationship between them. Therefore, human-object interaction detection has recently attracted increasing attention. Generally speaking, given an input image, HOI detection aims to localize and to recognize the instance, and then to infer the possible interaction among them. Generally, to address the task, an object detector is first used to extract subject and object proposals. In this case, to infer the interaction between the little boy and the cave. Most of previous works tends to just leverage the visual embedding features inside corresponding bounding boxes, and then feed them into the decided inference network to get the final detection results. However, the model may output similar probability to HOI human-like cave and human cat cave because of the similar embedding features. But if we take into account the features from subsidiary relationships between the boy and the knife, as well as the knife and the cave, the model may be more discriminated to the fine-grained action, line, and curve, and give a higher probability to HOI human cat cave, but lower probability to human-like cave. Moreover, knowing the detected objects, human, knife, and cave, underlying semantic regulation indicates that the inferred HOIs may be related to the cave as well as the knife. So, based on those insights, we propose a dual graph attention neural network that aggregates contextual, visual, spatial, and semantic information dynamically from primary subject-object relations as well as subsidiary relations. Concretely, our framework starts with an object detector to generate a set of object proposals. Then, we abstract the original image into two graphs. One is named visual graph, whose nodes are initialized with visual embedding features, and the other one is semantic graph, whose nodes are initialized with word embedding features. After passing through the proposed Visual-Semantic Graph Attention Networks, the model outputs the inferred human-object interaction labels. After instant detection, we can extract the visual features inside each detected bounding box and corresponding spatial features between each two detected objects. Besides, with the detected class labels, we can get its word embedding features with word-to-vector model. As aforementioned, we can construct the original visual graph and semantic graph with those features. In the graph attention network, we applied an attention mechanism to calculate the weight on each connected edge for each node and aggregate the neighboring node features with the weighted sum. After that, we can get the updated graph with new node features. Here, the thicker the edge is, the stronger the interaction between two connected nodes is. Then, we combine these two updated graphs into a new graph by concatenating the node features and initializing the edge with the spatial features. Finally, we leverage an edge real function to infer the action on those edges connected to the human. We train our model on the challenging high-code depth dataset and outperforms state-of-the-art HOI detection results. From the visualization result, our proposed model is able to detect various kinds of scenarios, such as a single person interact with a single object, multiple persons interact with the same object, multiple persons interact with the multiple objects, and so on. For more details of the method and results, please refer to the paper.